Hello. Hello, Mr.
Hello, and we're going to have our break time.
Everybody, hello. So today we talk about dot product. Okay, so that's the mathematics concept applies to vectors. So we use the array. Array is list as a vector. Yeah? You know the vector. What's vector? What's vector? What's vector? Can you tell me what's vector?
Well,
Vector, yeah, something like that. Yeah, we use has the what's called it magnitude and direction. Yeah. Okay, we'll come back to this concept, but as far as we can know here is that the vectors it can be represented by arrays list. So we want to compute the dot products for the two dot products. So we use what? A times B. Okay. A times dot product. Look, using this single dot. So what does it equal? It equals. It will give us a value, right? It's not a list value. So what does it equal? It equals to the sum. The sum, okay? Sum of let's say the number of elements in both elements are arrays are n, right? So it equals what? I equals 0 to n minus 1. Sum of a I times bi. Simple, okay? So based on this, can you give me the answer for the dot product of a and b? Come on. Come on.
well, it is.
Come on, it should be easier. AI times bi and sum it all together. AI times bi. So what's the answer? 1 times 4 plus 2 times 5 plus 3 times 6.
It's, wait. It is 4, 10, 14, 18, 14, 32.
32. Okay, wait. Do you get it? Yeah. So the dot product applies to two vectors of the same length, and then all we have to do is to sum up each corresponding pair. 1, 4, 2, 5, 3, 6. Right?
Yes.
Yeah. And if it doesn't have the equal length, then we can't apply this, right? It only applies to the same length. If another one, is there a dot product for these two?
No.
No, because there's no same length.
Can we just like 7 plus nothing?
So what do we? No. It has to be the same length for two. Okay. So do you understand this? Sum from I to 0 to n minus 1, ai times bi, and we want to sum of these, right? Correct?
Yeah.
How can we implement it? Easy, yeah. Define dot product a b. First of all, what do we do? What do we need to do? We need to find out the length, right? Yeah. So what's the length?
The length
N equals
is something.
length what? Length what?
Length. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
A, right?
A.
But we also have to check if b is the same as n, right? So we can use the function called assert. What does it mean by assert? What does this mean? Assert. Assertion. ASSERT. Assert.
Well,
What does this mean? In English.
you know.
You don't know. That's fine. Assert means that to make sure, to guarantee, to make sure. Yeah. Okay. So we need to make sure n equal length what b. Right? It has to be the same length, right?
I drew something.
Okay. So
You rubbed it out.
So what happens if this does not satisfy? If n is not equals, if the length of a is not, the computer will just scream. Okay, you scream at this point. It will tell you, okay, n is not equals to length b, and it will refuse to continue. Okay, so that's the way to make sure that after this, we don't need to worry about if they are not the same length, right? Okay.
How come your computer screens?
Just print an error saying, okay, I don't like what you are doing here because you tell me, okay, n is equal to length b. But what I found out is that n is not equal to length b. Then last I cannot continue. That's what basically it does here. Assert. Okay. Okay. So now we want to return a value which is at the beginning equals what? Come on, we want to sum up the beginning. What value? At the beginning.
A.
No. The sum. There's a value. There's a value. We want to sum up the beginning. What's the sum? It's nothing. So what do we give it?
Nothing.
0. Come on. For
0 is nothing.
I.
Yeah, 0 is nothing.
Okay. For I in range. Range what?
3.
We want to go through the index.
A and B.
What?
A and B.
You're not looking at the board. What's the range?
I am looking at the board.
Okay, so now we need to do the s plus equal what?
That's a big
And then we need to return what? Come on. Come on, return what?
I think it's S plus equals AB.
AI times what?
A B
B what?
I.
Way down. Okay, so let's basically adopt that. What's the time complexity? Way down. What's n?
No number is
Three in the tree.
What's the space complexity? Oh,
1.
yeah.
Just wrote it.
Yeah, okay. Okay, can we use some fancy syntax like a zip? Do you still remember the zip function? We talked about this before, yeah? Zip. Like 1, 2, 3, 4. And then this is A. B is 5, 6, 7, 8.
9, 10.
So what's zip AB? Come on. What's zip AB? You know what's zip? Yeah? So I have A.
You put them together.
Yeah. So I have A here, I have B here. Zip. So what happened? 1, 5, 2, 6, 3, 7, 4, 5. Yeah. And we also have a zip longest. Yeah. If it's different length. Yeah. If there's a 9 here, then you can use a zip longest. But and then this one will be filled with none. Okay. We mentioned that before. Yeah. So zip AB. So if zip AB, you will return a list of tuple. Yeah. So you become like that. Right. 1, 4. What? 2, 5. Yeah. Something like that. Yeah?
3, 6.
Yeah, okay. So we can use this.
4, 8.
Look,
5.
so we can do what? Return what? We can just do this. Sum. Okay, sum what? x0 times x1 for x in zip. What? Come on, you can guess. Sum x what's s? X is a tuple, yeah? X is a tuple. Yeah. Look, zip AB. Look, 1, 2, 3. And then if I zip with 4, 5, 6. So what do we get?
1, 4, 2.
1, 4. This is a tuple, yeah? 2, 5, 3, 6. Yeah. What's x? X is this one. So x is this tuple. X0 is here, right? This is x0. This is x1, right? I want to sum up x0 times x1, which is 1 times 4, 2 times 5, 3 times 6. And I want to add it together, sum, using the sum function. So this is quite fancy, yeah? Okay? Got it? Okay, so I'm going to erase this, and you need to implement one of it.
Oh!
Come on, you can use the implement the first one.
Anything.
We just talk about, okay, so first one, this one, dot AB. We need to add what variable? S equal. S equal what? 0. And then we need to go what? We need to what? Go through the list. We need to go through the index, right? For I in range. What? We want to accumulate the AI times BI. What's AB? Why you keep it? What?
I don't get used to AI.
S
Equals
plus equal, come on. A.
I.
BI.
What BI?
Time.
BI.
And what's missing here?
Return
Return.
S.
Well done. It's not hard, right? Okay, that's it for today. Good job.
Bye.
Bye.
Ow.
Sorry.